Hello, I'm Aaron Crane, and I'm here to talk about the evils of context and how to write code that works around it.
Massive round of applause!
So, this is the sort of thing I mean when I talk about problems with context. This looks like a nice, straightforward one-liner. You've got some program that's generated a Unix epoch time in its output, and you want to know what that is in your local time zone. So you copy and paste this 10-digit number into that command, and this is the output you get. And I have just one thing to say about that. Huh? It's pretty baffling. But if we put the say into a loop, then we get this, which is, I suppose, slightly more comprehensible. We get lots of numbers. Each element of the list we get back is a number representing some part of the local date and time. So that still kind of leaves us with the question of, well, what, why, how? And this is what Perl calls context. Each operation in your program can impose either scalar or list context on its arguments, and the Perl runtime keeps track of whether a scalar or a list is required, and it makes that information available to the operation itself. So, for example, ordinary arithmetic operators impose scalar context on their arguments, and the for loop imposes list context on the list it iterates over, kind of unsurprisingly. And there is actually also a third execution context, void context, where the calling code never looks at the operation's return value, and that happens for statements which aren't the last one in their block, like the call to throb here. Now, neither a scalar like $x nor a numeric constant like 1 pay any attention to context. They just give you the obvious thing. But there are quite a lot of operations which do different things in different contexts, like local time, and, as I'll show shortly, quite a lot of code on CPEM. So here's how local time handles context. If you call it in list context, it gives you the list we saw, and the say built-in evaluates all its arguments in that context, so that's the output you get. But you can use the scalar built-in to force scalar context evaluation, and then you get a nice convenient string, which is probably what we wanted in the first place. So this use of scalar local time demonstrates what I think is the biggest fundamental problem with context. Perl doesn't always guess right about what you wanted, so sometimes you have to override its decision. But I'm going to start by looking at three specific sorts of places where Perl's notion of context sensitivity causes problems for code maintainability in particular. So let's start by looking at the HTTP response class from CPAN. It's pretty widely used because it's part of LWP user agent. And suppose you've got a loop over some responses that checks whether the content type that the server sent back with the response is interesting before then going on to do some other processing. So we look at the $type, the response's content type, and we skip this item if it doesn't match the criterion we have. So that's all good. But then, some months later, another maintainer comes along, and they notice that this type variable, $type, isn't used anywhere else in that loop. So they refactor to eliminate it. And that looks completely safe, right? We just took out the $type declaration and moved the thing it was initialized from into the place that used it. Completely safe? Well, no, not really. Previous code used a scalar assignment to get the return value of the content type method into the variable. So the method was called in scalar context. But all subroutine parameters, almost all subroutine parameters, are evaluated in list context. So now that the new code has the method call as an argument to matches, the method must get called in list context too. And why does that matter? Well, HTTP response is documented to behave a little differently in list context. If the response's actual type has a charset parameter on the end, the content type method returns a list of two elements: the base type text/HTML and the parameter charset equals UTF-8, which in this situation means you've probably got a bug. Your matches function gets the charset thing where it's expected the criterion to match on. And worse, this bug is data dependent and in a pretty surprising way. So if your code's test coverage isn't that great, you might well find this bug is going to leak out in production, and then bad things happen. So this is the first problem situation of context. All subroutine arguments, like in the call to matches here, are evaluated in list context, so obvious looking code doesn't necessarily do what you expect. The second problem situation for context is actually pretty similar. When you construct a hash, everything in the hash is evaluated in list context. So, not to pick on HTTP, well, actually, I am going to pick on HTTP response because it's its fault. But suppose we've got some code like this. We fetch the response as content type in Scalar context, then we put that into an anonymous hash, and we'll make the same sort of supposition we did last time about a future maintainer trying to keep the code clean and eliminate unnecessary variables, and with that unused $type. And then we've got code that's cleaner and shorter, but also buggier, and non-obviously buggier. Because if the actual type has a char set on the end, the behavior is actually going to be more like this. Rather than having type going to content type and URL going to URL, we've got type going to text/HTML, char set equals UTF-8 going to the URL, and $URL going to, well, nothing. So you'll probably get an odd number of elements warning, and later on you'll probably get an uninitialized value warning when you try to access the URL element of the hash. But otherwise, it pretty much sucks to be you. And for this sort of problem, with list context used for creating a hash, you can get some really nasty examples with CGI.pm.
We can do a program without using a manual.
What I'm talking about is what happens when you're looking at the code in front of you, not whether you... And I'll take questions later, that's happening from you. So, where was I? CGI.pm. Now, do bear with me. I realise that we've got much better choices nowadays than raw CGI.pm, but some of those choices have replicated the relevant part of the CGI.pm interface, even if only for legacy reasons. And it's the part that causes the biggest context-related problems, so I think it's still relevant. Let's suppose we're writing part of a search engine, and we want to handle URLs like this, the Q parameter containing the search query. CGI.pm has a param method, which lets you get the value of a form parameter. It actually does far too much other stuff as well, including letting you call it a global function and la 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 la. That's not relevant here. Let's just concentrate on $CGI arrow param Q. So you can call that, and in this case you get the appropriate string. However, HTTP allows multiple form parameters to have the same name, like this tag parameter. So CGI.pm uses context sensitivity to transparently and magically give you just one element if you call it in Scalar context, or all of them if you call it in list context. And that's going to work just fine here. You can pull out the single Q parameter in Scalar context, and both of the tag parameters in list context. But again, let's consider another simple change. So now we're using the form parameters to build an anonymous hash, which we're then going to use for actually searching with. And this still works until, oh wait, no it doesn't. What happens if some malicious user invokes this URL with two Q parameters? Well, oops. Now it's as if you called that search method like this, where the extra form parameter swaps keys and values around in the hash you're building, and all under the control of the untrusted entity on the other end of the network connection. So, you know, bonus points if that causes a security vulnerability in your code. And if you've ever tried to debug something like this, I'm pretty sure you'll share this sentiment. So that's the second problem with context, hash construction. And the third one is the way context propagates into return values. So what do I mean by that? Well, let's look at this code. It looks fairly similar to an earlier example. You'll notice these are all basically the same example. But I'm going to point out one additional wrinkle. Again, consider what happens if someone makes an obvious looking change to the code. Is this change actually safe? Well, that's hard to say. It really depends on how the f function gets invoked. If all its callers call it in Scalar context, like this, then that's fine. But suppose someone calls it in list context, perhaps in one of the awkward situations we've already seen. So the return statement in the f subroutine evaluates its expression in the context that f was called with. So now we get the unanticipated, data-dependent second return value from the content type method. And this propagation of context into return statements means that if you have a long chain of subroutines that return the result of calling other subroutines, the code that you can fix by inserting Scalar might be arbitrarily far away from the code that's meant to be context sensitive. And just to go back to the original code for a moment, so we had this, we made a simple looking change to that code to remove the extra variable, and we ended up with code like this. So that's not as safe for refactoring as you might think, But suppose you'd started with this code, and you wanted to change it to conditionally modify the type returned, but otherwise leave the behavior unchanged. That is, we're going to want the inverse refactoring. Introduce a temporary variable containing the value we're about to return. This way around, there isn't even a simple way to express that. You need something like this. That is, you need to carefully reproduce the surprising context sensitivity of the content type method. So you break out the annoyingly misnamed want array built-in and conditionalize based on what it tells you. Quite annoying. So those are the places where context causes problems. And of course, I'm not the only person to notice that context can be surprising. So in particular, Damian Conway's book, Perl Best Practices, has some advice for how to deal with context and the problems it causes. And Perl Critic attempts to detect violations of Damian's recommendations. Now, I think Damian's analysis of the problems with context is actually pretty solid. But the problem I have is that his recommendations don't actually help, I think. So I've got 3 specific disagreements with what he says. So the first thing is this. He says, make list returning subroutines return the obvious value in scalar context. And Damian then goes into some detail about how to decide what the obvious return value is. And he makes the good point that if you could ask potential users of your code what they'd expect. And he has some specific advice for what to do if you don't have a ready-made community of people to ask. But for me, I just don't see how this helps. As I see it, the problems are caused by having subroutines whose behavior isn't obvious from looking at their call sites. So choosing any scalar context behavior is just asking for trouble. And thinking carefully about the least bad option, well, sure, that's a good idea, but it doesn't alter the central issue that functions that capriciously change their behavior according to context are hard to use correctly. So the second PDP recommendation I disagree with is this. Where there is no obvious scalar context return value, consider contextual return instead. Now this is one of Damian's modules. PDP offers this sample use. That is, rather than just returning a value directly, you use these utility subroutines called things like bool and num and list and so on to build up an object which has overrides that let you convert to a bool or a number or what have you as appropriate. So then a caller can do something like this. You can call the same getServerStatus subroutine in a variety of ways, and it will then do its best to give you what it thinks you want. Now I think this is even worse than the previous piece of advice. If context sensitivity is part of the problem, then this clearly exacerbates it, right? If only because it provides many more contexts that code can be sensitive to. So I suppose a future user of this getServerStatus function has only seen it called in the first way shown here, the $total load plus equals getServerStatus. But if they don't know about this contextual return stuff, it's reasonable for them to assume that they can do this too. Right? Clearly the sort of thing you might do for debugging purposes. But if you had no idea that this was going to happen, you're going to be flummoxed to find the server's name and uptime getting printed out rather than the load average. So the third of Damian's recommendations I disagree with is this. Use a bare return to return failure. And his motivating example looks like this. So we've got this subroutine guesstimate which gathers some numeric estimates, and normally it just wants to return those estimates in this context, or their average in a scalar context, but if calculating any estimate fails, it just wants to bail out. And Damian correctly points out that the first return statement here, well, the return undef, causes problems for some calls to this function. So in examples like this, for example. So let's unpick that. Call to guesstimate is on the right-hand side of an assignment to an array variable. So that means it's a list assignment, so guesstimate itself is called in list context. But that list assignment itself is in the antecedent of an if statement, so it gets run in scalar context. So what does that mean? Well, a list assignment in scalar context yields the number of elements on the right-hand side, roughly. If guesstimate found no invalid estimates, that works just perfectly. And it's also fine if it found no estimates at all. The right-hand side is empty, so the assignment returns 0, which is false as far as the if is concerned. But remember what guesstimate does if it finds invalid estimates. It just returns undef. But in list context, an undef is a single element list containing an undef. So the list assignment's scalar context return value is 1, and the if succeeds even though we don't have any valid estimates. On the other hand, if guesstimate simply used bare return, what would change? There'd be no difference in scalar context, because bare return does the same thing as return undef in scalar context. But in list context, it returns an empty list, and that would make the list assignment in the if do just what you wanted. So that reasoning of Damian's is hard to fault, but it fails to take account of a different situation. So take a look at this subroutine. We take a server object, return a failure value if the corresponding physical server is down, and otherwise return a hash graph with some other specific bits of data we have. And you'll notice that server status summary follows Damian's advice on this issue. It uses a bare return in the failure case. So what happens when it gets called? Well, it's all good if you call it in scalar context. If the server's down, bare return gives you an undef, which makes the or next kick in, and we move on to the next. So that's good. But what about if you call it in list context? Well, okay, we've got some code like this, we're building a hash. What happens if the beer server is down? Well, remember that we had bare return in server status summary, so in list context that produces an empty list, and therefore now, despite following this wonderful advice, we get the same thing we'd have got for this code, and that clearly isn't what you wanted. And more generally, there's only one thing that bare return gives you and return undef doesn't, which is the ability to call it on the right-hand side of a list assignment, and then use the scalar sense of that list assignment. But in this case, we were expecting a single value from the subroutine anyway, so this seems like a particularly bizarre thing to optimize for. So, if those are the problems with context, and Damian's advice doesn't really help, what should we do? Well, you'll surely be relieved to hear that I do have some advice for how to write code that isn't susceptible to these problems. The first rule of context is simply this: don't write context-sensitive subroutines under any circumstances. Thank you very much. They aren't as helpful as you think, because their behaviour is rarely obvious to maintainers. Instead, you're better off having one routine for each type of return value, or at the very least, take an explicit argument saying what the expected return is.
Just return an object and let the call it.
Or which comes out to be the same thing, yes.
Documentation.
People don't read documentation.
Questions
in a minute. So, this means that if you're going to this, you have to decide whether each function or method you write is going to be called in void context, or scalar context, or list context. And even Damian seems to pretty much agree with that. He talks about list returning subroutines, so he clearly does distinguish them from other subroutines. And once you've adopted this position, then the context-specific advice is a lot more straightforward. Use bare return in void functions. It's often a good idea for them to have an explicit bare return, so that even if they get called in non-void context, they won't accidentally happen to return the last thing they happen to evaluate. And this is actually, of course, one of Damian's recommendations, but I agree with it, so yeah, that's good. Next, make sure that your scalar functions return exactly one value. In some cases, that's easy. If you're returning a scalar variable, or a constant string, or a number, or whatever, there's no possibility of context confusion. But if the thing you want to return is a context-sensitive expression, you can help your callers out by making sure that they get the scalar return value that they were expecting. And at the same time, you'll help your future maintainers out by making sure they can see what the caller's going to get. Finally, if a list context subroutine is called in scalar or void context, I think that's undeniably an error in the caller. So it's probably a good idea to detect that case and report it as early as possible. Confess, you shouldn't have called me in scalar context if we're not in list context. And I do think this is one of the very few legitimate uses of one-to-array, by the way. In most cases, I find using one-to-array in your code should be a red flag that you're doing something wrong. Now, I think some people might say something like, but can't we just return an array ref when called in scalar context? Well, I don't think that's a good idea. As I've shown, there are a lot of potential problems when dealing with context. And I think any use of context sensitivity is just too dangerous to rely on, too hard to rely on. And it hardly even saves any effort in the caller. If you can just wrap the call in an anonymous array, that's trivially easy to understand, both at the call site and in the subroutine itself. And I think it's a pretty perfect example of self-documenting code, at least at this scale. Other people might suggest that if context is so awkward, perhaps we should just use scalar context everywhere. Just always return an array ref. And the problem with that is that then you end up fighting the way the language encourages you to work, which makes all your code clunkier and more painful. Quick example, Suppose we've got this $tree object representing some kind of tree, and there's a find method which takes a regex as an argument, finds all the nodes in the tree whose label matches the regex. There's also a children method which gives you all the children of a given tree node. And suppose you want to iterate over all the children of all the nodes whose name match your regex. So if these two methods return array refs, you have to do something awkward like this. And there's various ways to write it. They all get icky. It's an awful lot of @curlies for something that ought to be really simple. But if you have a list returning API, then it all gets much clearer and more comfortable. Yeah? You say map $_ our children over $tree arrow find $regex. So that pretty much wraps up what I have to say. Regardless of anything else, Perl code has to deal with the fallout from context sensitivity in built-ins and in CPAN modules. But at this point, I don't think we've got any alternative. However, I am convinced that these recommendations are a pretty good way to keep your own code clear, easily comprehensible, and free of weird context oddities. And I would encourage everyone here to consider adopting them. Thank you for listening. So I will take questions. Are there any questions from people not in the second row? David!
There is another type of context. You can call, you can have a subroutine which you can call as a subroutine, or as a class method, or as an object method. Don't write them, ever.
Yes, I agree with that. For those who didn't hear, don't write subroutines that can be called as object methods or class methods or subroutines. Pain, suffering, hard to understand. Thank you, Dave. Yes?
Is there some cases where context is okay?
Other situations when context is okay. Sometimes you're dealing with code that uses context. That's unavoidable. Sometimes you want to be able to say, I care about what context I've been called in, so I'm going to throw an exception if it's not what I expect. My view is that for new code, unless you're doing something that's kind of deliberately trying to, to deal with the context sensitivity in other places, your code is just going to be more complicated if it's context sensitive. My view would be no when ideal. Sometimes for pragmatic reasons you need to work around the problem you're facing. Sorry, I've got to take peers now.
The suggestion I'd make is always use, if you're expecting a single value in a hash on the right hand side of a broad array, always use scalar. Even if the function you're calling is not context sensitive, you've signified that you're expecting a single value.
So for those who didn't hear, here suggests you've been building a hash, put scalar on the right hand side of every pair. Yes, it does guarantee that it's very clear, you know exactly what's going on, you get that thing I like, which is locally very understandable code. The disadvantage is that building a hash now takes an extra keyword per element, which is potentially irritating. Stephen?
Right, so I have a refinement of one of your suggestions. You said a list returning function should die if it's not called in list context, or another version of it is you've had two versions, is it should die if it's called in scalar context. I agree that it should die if it's called in scalar context. I think it should not die if called in void context. Generally, we do accept the idea of calling a function just for its side effect, and you didn't give any recommendation of scalar functions dying if called in void context.
Yes, so again, for those who didn't hear, Stephen say, well, void, it might be okay to call things in void context, deliberately discarding the value, and in those situations, perhaps your callee shouldn't complain about the context it gets called in. Yes, that would be a reasonable way of looking at it. I'm okay with that. It doesn't feel necessary to me, but because I rarely have value returning subroutines, so especially not for a list. I've got a subroutine which is going to return a nice long list of things, but I'm going to throw that list away. Relatively unlikely in the car, right? But yeah, there are cases where allowing void context would be the right thing. I go with that.
So we're going to have to leave it there, I'm afraid, the next talk's in a couple
sorry.
of minutes.
If you want to grab me, please do.
Yeah.